Hello guys, in this video we're going to work on page 319, 320, 321, problem 1 and 2. So in this section 5-6 is about the fundamental theorem of algebra. So please look at the book to page 319. There are 3 graphs in there. And then these graphs are telling us how many number of zeros we're going to have. Actually, 0 means a root, which we have been working with it. So the degree of polynomial equation tells you how many roots the equation has. Similarly, the graph is telling us how many zeros we're going to have it. So how do we know it? We have to count how many x-intercept we have so that they will directly tell us how many zeros we are going to have. So the first graph, they are having this form. And please count how many intersection we have. We have 2 intersection, right? So you can say that has a 2 real 0. What about this type of situation that I have? Graph which is a touching x-axis. Then how many intersection we have? Only 1 x-intercept. There will be 1 real 0. And then you may have this graph, which is the last one, which means your graph is not touching x-axis. Do we have any real solution? No, we don't have anything. So we have a no real 0, which means that we are gonna have 2 imaginary zeros. Okay, so this comes from the fundamental theorem of algebra. So I'm going to share this. Alright, so the fundamental theorem of algebra is made from German mathematicians. The name is Gauss. Says that every polynomial has at least 1 0 in the complex numbers. What does that mean? The linear factorization theorem states that every polynomial f of x can be factored as a times x minus c1, x minus c2, and x2, x minus cn, which is they're going to have all the, zeros. So therefore, every polynomial has exactly n zeros among the complex numbers. So simply states that you're having the cubic equation. Then you are going to have 3 roots. If you have square polynomial, which is a quadratic equation, then you are going to have 2 roots. If you are having quadratic equation, which is degree 4, how many roots are we going to have? 4. Okay, so I'm going to move on to the problem 1, to working with the fundamental theorem of algebra. So let's go back. Problem 1. Page 320, problem 1. What are all the roots of x to the 5th power minus x to the 4th power minus 3x squared cubed plus 3x squared minus 4x plus 4 equals 0? Okay? So my first step is going to find out that my possible rational roots. We learned the rational root theorem, right? We have to look at the factors of my constant here, and then the factors is my leading coefficient. Oh, there is no number. What does that mean? There is 1, right? So my first step, I have to find out my possible rational zeros, which is factors of 4 plus or negative 1. Plus or negative 2, and plus or negative 4, all over plus or negative 1. So it's just giving you plus or negative 1, plus or negative 2, and plus or negative 4. Alright, so my second step, we're going to find out actual root. So what we're going to do, we're going to try and check that which one is going to be working. So let me use +1 this time by using synthetic division. Alright, so let me set up my synthetic division from the given equation. So how can we set up the synthetic division, guys? You have to pull all the coefficients out. So I have 1, I have 1, I have -1, I have -3, I have +3, I have -4, I have +4. Now what? You need to put the upside down division symbol, and I'm going to try with my +1. What was the steps? You need to bring the first number down, multiply 1 and 1, write it down here, and you're going to add every single time. They will be 0. Now what? 0 times 1 is 0. Add them up. That's -3. -3 times 1, -3. If you add them up, there will be 0. 1 times 0, there will be 0. -4. -4 times 1 would be -4. Okay, my remainder is 0. What does that mean? This equation can be factored by x minus 1. So my step 3, I can rewrite my given equation like this, which is x to the 5th power minus x to the 4th power minus 3x cubed plus 3x squared minus 4x plus 4 can be written as my factor x minus 1, and then understand my 5 numbers in terms of quotient. What is it? I had a quintic. Now I divided by x. That will be quartic. I starting with x to the 4th power. X cubed is going to be not shown because I got 0. And x squared. And then the x is going to be nothing and minus 4. Okay, so you have to factor it as much as you can. So do you think it's going to be factored out? Yes, it is, because x to the 4th power, x squared, we practiced this one before. So let x to the 4th power as x squared minus 3x squared and minus 4. Then it will be easier to understand that. So let a large x would be x squared. Then I would have x minus 1, x squared minus 3x minus 4. Okay, I am familiar with this form. Factors of 4, 1 and 4, and they are 3 apart. So which one has to have a minus? Which is 4 and plus 1. But we know that this x is not original form. We have to replace the back of my original one, x squared. It will be x squared minus 4 and x squared plus 1 this time. Now you can keep going. Oh, I know this one. X minus 1 times x squared minus 4. 4 is perfect square number. I would write it down. Sum and difference, like this. And then I have x squared plus 1. I have to factor it as much as I can. You can be factored with I, because x plus I and x minus I, they can make x squared plus 1. Okay, so I'm done. Now my last step, I can list of my all roots. What is my root? 1, -2, +2, -I, and +I. So, by the fundamental theorem of algebra, these are the only roots, which means I had quintic equation. Now, how many zeros do I have? 1, 2, 3, 4, 5 zeros, which is 5 roots. All right. So I'm going to give you time to work on Got It 1 by yourself, and then you're going to check your answer with me. Alright, Got It 1. What are all the roots of equation x to the 4th power plus 2x squared, x cubed, equal 13x squared minus 10x? First, you have to make that as a standard form. which is move everything into one side, then I would have this. Okay? And then now what I need to do after this. You are going to factor this one out. So let's look at it. Do we have any common factors here? Yes, we do. What is it? X is gonna be our common factor. So you can pull that out. Then I got a x cubed plus 2x squared minus 13x plus 10. That would be 0. After that, think about it. I can think about the, possible rational root so that I'm going to find out what will be. So think about the factors of 10, which is plus or minus 1, plus or minus 2, plus or minus 5, and plus or negative 10 over plus or negative 1. So it will be just this, right? So this is my possible rational root. I'm going to find out the right one. So it's up to you which one you're going to try with it. I'm going to try with 1. So now you need to set up the synthetic division again. Pull all the coefficients out, 1, 2, negative 13, and 10. And then upside down division symbol, you're going to put 1 here. It's up to you that you are going to use something else, then go ahead. So bring down 1. 1 times 1, 1, 3. I got 3, negative 10. Okay, so I got my remainder as 0, which is good because I got my root, which is 1. Now what? I can understand my 3 numbers as a quotient. What would it be? X squared plus 3x minus 10. Right? So let me rewrite this one down again. So from that, I can write it down this. X times x minus 1 times x squared plus 3x minus 10 equals 0. Do you think the last one can be factored out? Yes. By what? 10. How can I make it 10? 2 times 5. 2 and 5. 3 apart. Since 3 is positive, which one needs to have positive? Bigger number. Right? So now, I can find my all roots. How? From here, I got 0. Here, 1. Here, negative 5. And here, 2. Since I have, quartic equations, so by the fundamental theorem of algebra, those 4 of them are the only roots. Alright, let's move on to the next page. Alright, I'm on page 321. Problem 2, finding all the zeros of a polynomial function. So now we're looking at the function. So we're going to find out zeros. So my problem 2 question looks like this. What are the zeros of f of x, which is x to the 4th power plus x cubed minus 7x squared minus 9x minus 18. You guys are allowed to use a graphing calculator this time, so you can use a Desmos.com, or you can use an application from the App Store. You guys are going to download a graphing calculator. So please type all about that, and then you can see the graph. If you don't have a graph, please look at the book to page 321. They already show you the graph, right? So their graph. Step 1, we need to find their graph. So their graph looks like this. They're having the graph something like this. Alright, so we are going to find out the root from zeros from there, which is x-intercept. How many x-intercepts do we have? 2 of them right here, 1 and 2. So they said a 0, one of the 0 would be 3, and then the other 0 would be positive 3. Alright, then which means I can factor my function by using those two numbers. So my step 2 is asking to factor this one out. So what number do you want to use that? I want to use negative 3 first. So starting from my given function, you are going to pull out all the coefficients, which is 1, which is 1, which is negative 7, negative 9, negative 18. And upside down symbol, you're going to start with negative 3. You can start with the 3 first, it's up to you. Because anyway, we already know that 3 and negative 3 are our zeros. So anyway, we're going to bring one down. Multiply them up, negative 3. I got negative 2 here. Negative 2 times negative 3, positive 6. Negative 1, positive 3, negative 6, 18. So you end up having not 0 for your remainder, which means your work is wrong. You have to double check it. Now I'm going to apply with my synthetic division again with 3. So bring one down. 1 times 3 would be 3. Add them up, there will be positive 1. 1 times 3 will be 3. If you add them up, there will be 2. 2 times 3, which is 6, and my remainder, 0 again. So my 3 numbers here will be my quotient. What is my quotient? X squared plus x plus 2. That would be my quotient. So let me rewrite my expression like this. X to the 4th power plus x cubed minus 7x squared minus 9x minus 18 can be written as product of x plus 3 and then x cubed minus 2x squared minus x minus 6, but I could go one more step by using 3, so you got a x squared plus x plus 2. Okay, now what? You are going to find out all your zeros. So you're going to look at okay, what kind of 0 can I find from here? Do you think that will be factored out? Not really. So what way we are going to use it? The powerful method, quadratic formula. So I'm going to apply my quadratic formula for this. So set up as a x squared plus x plus 2 equals 0 on my step 3. Alright, so my A is 1, my B is 1, my C is 2. Applying to the quadratic formula, what is it? Negative B plus or minus square root of B squared. 1 squared minus 4 times A times C all over 2A. Now, you're going to simplify after. What is it? Negative 1 plus or negative square root of 1 minus 8 over 2. So I already know that, my answer would be imaginary number because I have a negative number within my radical. So negative 1 plus or minus negative radical 7 over 2. Negative radical 7 can be written as what? I. So you got a I radical 7 over 2. So what is my 4 zeros, which is my x would be what? Negative 3 and 3. And then negative 1 plus I radical 7 over 2. And then negative 1 minus I radical 7 over 2. So you're having 4 of them. So by the fundamental theorem of algebra, there can be no other zeros. This is only 4. Okay? I'm going to give you time to work on Got It 2 by yourself. Alright, let's go over together. Got It 2. A. What are all the zeros of the function g of x equal 2x to the 4th power minus 3x cubed minus x minus 6. So in here, we are going to find out the 0. So you are going to use graphing calculator. So graphing calculator. Okay, my y would be 2x. Where's my x? My x. Why can't I find my x? X to the 4th power. I got a green x. Alpha x to the 4th power, right? And then you're going to move minus 3x to the 3rd power, move minus x minus 6. Okay, I have to graph this one. So enter. Whoops. Oh, this x. Okay. I have to delete this. Delete, and I need to put my x here and 6. Okay, what's happening? Oh, they just write down as ascending order. So graph. Okay, here's my graph. So see. This is my graph. I have to find out my 0. So did you see the intersection right here? I got can I use my pen? No, this is not gonna be working. Alright, so you can see your intersection here, which is -1, and then here 2. So from that graph, I found out -1 and 2 for my 0. -1 and 2. -1 and 2. Okay, so on -2, and then 1 is going to be my 0. So I'm going to use this one to do the synthetic division. So I'm just got back to the got it 2a. Okay, so got it 2a. I have 2, -3, and I don't have any x squared. Fill in the placeholder. -1 and -6. And you can either use -2 first or 1 first. It's totally up to you. Let me do with -2. Now what? Bring 2 down. 2 times -2, -4, -7. And then I got +14. So you got a 14 here. No, it's something not correct. 2, -3, 0, -1, and -6. Let me go back to the graph. 2x to the 4th power minus 3x cubed minus x minus 6. I graphed it. Oops. Graphed it. Oh, I'm sorry. -1 and 2. See? -1 and 2. Let me fix this. -1 and 2. Which means, how do I know it? Because when I do my synthetic division, it should give me 0, but it doesn't look like that. So on -1 and 2. Now what? -1. Bring 2 down. 2 times -1 is -2. -5. +5. And -1 times 5 is -5. -6. +6. Okay, it sounds good. It seems good. Now what? I'm going to use my 2 again. to the synthetic division again. Bring 2 down. So I expect I'm going to have a 0 at the end. So 2 times 2 would be 4. Negative 1. Negative 2. Positive 3. Positive 6. Okay. That looks great. Now what? Those 3 is going to be my quotient. 2x squared minus x plus 3. So let me rewrite it, my equation like this. Alright, so my given equation, 2x to the 4th power minus 3x cubed minus x minus 6, that was my expression, would be written as x plus 1, x minus 2, 2x squared minus x plus 3. So I have to factor my last one if it is gonna be working. But what do you think? 2 and 3 is a 6. I cannot really make negative 1, so I know that it's not gonna be factored out. So what should we apply it? Quadratic formula. So 2x squared minus x plus 3 equals 0. Where is my a? A is 2. B is negative 1. C is positive 3. Now what? Negative b plus or minus square root of b squared minus 4 times a times c all over 2a. That's my x. And then I can simplify this as 1 plus or negative square root of 1 minus 4 times 2 is 8 times 3, 24 over 4. Since I have, it's too long, have negative 23, negative number, that is plus or negative 4. I can rewrite my answer as what? 1 plus or negative I radical 23. Since 23, I cannot really simplify fully. This is already simplified. I cannot really pull any number out of the radical. You can just keep it like that. Alright, so for my last step, you're going to listing all your zeros, which is what? X equal negative 1, 2, and 1 plus I radical 23 over 4. And my last one, 1 minus I radical 23 over 4. So by fundamental theorem of algebra, we have only 4 zeros. Alright, next one, B, reasoning. The graph of f of x equal x to the 5th power plus 4x to the 4th power minus 3x cubed minus 12x squared minus 4x minus 4 is shown at the right. So you can see the graph right there. I, use the turning point to explain why the graph does not show all the real zeros of the function. So according to our given function, that is a 5th degree, which is the quintic function. So a 5th degree polynomial function has 4 turning points, 2 turning points, or no turning points. So 3 turning points are visible now. How do we know that? Because our graph looks like briefly like this, 1, 2, and like that. So how many turning points we have? 1 turning points here, 2, 3 turning points. So 3 turning points are visible, so they must be a 4th one, because 5th degree polynomial function has 4, either no turning points, but we already have 3 turning points. It should have 4 turning points. So this will turn the graph back across the x-axis. Alright, and then my second question, this is the answer for the first one. And second one, the graph of a g of x equal f of x plus 4. is a translation of the graph of f up 4 units. How many real zeros of G will be the graph of G show? So if you move your graph 4 up, what's gonna happen? So when I look at my graph on here, I think we can plug that into the graphing calculator to see that how many zeros we can find it. So I can open my calculator now. So this one should be deleted. Okay, now, so I'm going to plus 4 of f of x, then it will be something like that. X to the 5th power plus 4 times x to the 4th power minus 3x cubed minus 12x squared, and then minus 4x, because minus 4 plus 4, it will be just 0. So I got x to the 5th power plus 4x to the 4th power minus 3x to x to the 3rd power minus 12x squared and minus 4x. Now what? I'm going to graph it. And then, okay, that is advertisement. Okay. So now, this is my graph. So look, we're going to find out the intersection. Do you want to see the full graph? Wow, look. I have to shrink because I know that it's going to be, it has something in here, right? So for now, we're going to look how many zeros. So, your graph looks like this. I just pay attention on the intersection part. Okay, so can we count? 1 here, 2 here, 3 here, 4 here, and 5. I can actually see 5 of them, right? Because when I see that when I really graph this, it looks like this. Look, I have a 1, 2, 3, 4, 5 intersections. So how many real zeros G will the graph of G show, which is, 5. So by fundamental theorem of algebra, that there will be the 5 roots, right? And then we actually find out all the 5 of them from the graph. So, that's it. We're going to have 5 real zeros this time. Okay? So I hope this video helped you understand, and then we're going to see the next video. Bye.